Predictive modeling, also known as supervised prediction or supervised learning, starts with a training dataset. The observations in a training dataset are known as training cases and are also known as examples, instances, or records. The variables include inputs and a target. In the dataset used for the Churn Business Challenge, some of the inputs are number of calls to technical support, account tenure, age of customer's device, and device manufacturer. The target indicates whether customers churned. Inputs are also known as predictors, features, explanatory variables, or independent variables. The target is also known as a response, outcome, or dependent variable. For a given case, the inputs reflect your knowledge before measuring the target. A variable can be numeric or categorical. Numeric variables are also known as interval variables. Numeric variables can further be classified as continuous or discrete. Continuous variables can take on any one of an infinite number of values within a given range. Income is an example of a continuous variable. Of course, for practical reasons, income is typically rounded to no more than 2 decimal places. Discrete variables are counts. The number of items purchased is an example of a discrete variable. Categorical variables take on qualitative values, each value representing a group or category. The number of possible values of a categorical variable is typically finite. Categorical variables are often nominal, which means that the categories have no particular order. Occupation is an example of a nominal variable. Ordinal variables have categories with an inherent order, for example, shirt size. Binary variables have 2 categories, such as a positive or negative response concerning home ownership. The purpose of the training data is to construct a predictive model, that is, a rule that relates the inputs to the target. The predictive model is a concise representation of the association between the inputs and the target. The outputs of the predictive model are known as predictions. Predictions represent the model's best guess about the target given a set of input measurements. The predictive model makes predictions based on what it learns from the source data. A predictive model can generate one of 3 types of predictions: decisions, rankings, and estimates. Decision predictions are the simplest type of prediction. Decisions are usually associated with some type of action. For example, classifying a case as a churn or a no churn. For this reason, decisions are also known as classifications. Decision predictions are used, for example, in handwriting recognition, fraud detection, and direct mail solicitation. Decision predictions usually relate to a categorical target variable. By default, Model Studio assumes decision predictions when the target variable is categorical, binary, nominal, or ordinal. Ranking predictions order the cases based on the relationships between the input variables and the target variable. The most common example of a ranking prediction is a credit score. Using the training data, the model attempts to rank the high-value cases higher than the low-value cases. For example, the model might produce a list of customers ranked from highest priority to lowest priority. The actual rank values are irrelevant. Only the relative order is important. Note that ranking predictions can be transformed into decision predictions if cutoffs are defined for the ranks. For example, it is possible to make a binary decision by classifying all ranks above a cutoff as event cases and all ranks below the cutoff as non-event cases. Estimate predictions approximate the expected value of the target, given the input values. For cases with numeric targets, this estimate can be thought of as the average value of the target for all cases that have the observed input measurements. When the target is categorical, the estimate might equal the probability of a target outcome. Prediction estimates are most commonly used when their values are integrated into a mathematical expression. An example is 2-stage modeling, where the probability of an event is combined with an estimate of profit or loss to form an estimate of unconditional expected profit or loss. Prediction estimates are also useful when you are not certain about the ultimate application of the model. Estimate predictions are versatile because they can be transformed into both decisions and ranking predictions. Thus, if you are not sure which type of prediction to use, it is best to go with estimates. In Model Studio, most types of models can be configured to produce estimate predictions.